My name is Nia. I'm a postdoc at C4, and I'd like to share some preliminary results and would really appreciate a lot of input on this research about the cause of peat fires. So here, we're studying the cause of fire in peatlands, and this includes shallow and deep peat, but from the emissions point of view, the deep peat contains a lot more carbon, but we look at all of it and then see what comes out. And these causes are mostly human activities in the area, because in tropical peatlands, I find very little evidence that there's any naturally occurring causes of peat fire that's not human related. Most of the activities we found are by people living or working in the surrounding villages, and because there are no large-scale actors around, so no oil palm concessions and things like that inside the area that we're studying. So here we focus on activities that are done in the dry season, activities that may cause fires that happens on peat soils. And here, the definition of thin peat here is a little different from Lala, is 0 to 2 meters, and then thick peat is more than 2 meters. And I have quite a hard time grappling why this is the case, but I'll just choose this to start with. So why are we studying this? When I started research on carbon leakage, I assumed that the cause of emissions in a particular area is known, and what remains is the mystery of how things are displaced and how to attribute those displacements on a RED activity or a RED intervention. However, it turns out that there's little that's known about what human activities cause the fires to start and spread in peatlands. So here, I'd like to highlight that understanding what ignites fire is not enough, but these fires have to have a follow-up of whether they spread or not. So to understand the ignition and the spread, one has to understand the environmental and social and spatial links of a particular activity. And this knowledge could be useful for targeted incentives to change these carbon-emitting behaviors, and also identifying people who might be affected if there's a fire management or other related interventions that come. And understanding displacements of fire and attributing changes in fire occurrences in the area to RED intervention, because sometimes there are changes in fire events, reductions or increases, but it might be caused by something else and there's no clear link. But without understanding these activities in detail, it's quite difficult to conduct that attribution process. So this is the study site. It's in central Kalimantan in the ex-mega rice area. It is between what is called Block E and Block A of the ex-mega rice project area. And from the fire's perspective, these two blocks, this is the boundary of the project. And the boundary of the project that's inside Block E looks very different from the one in Block A in terms of how fires occur. In Block E, there's relatively intact peat forest on top, and fires are mostly on the on thin peat. So all these are hot spots and located mostly there, non-peat or mineral soil, something like that. And in general, there's less hot spots on the north side. And the cause, it looks like here, at least inside the KFCP area, it follows a line, and that follows a road that's being opened at that time. This is a 2009 hotspot, by the way. That's the last time there's a significant dry season. In Block A, it's mostly degraded. All these are canals, and so the peatlands are drained, they're dry, and there's a lot of fires because of the drainage of these canals. So this part is a major concern for trying to reduce emissions from fires, and also from the drainage itself. And there's a lot more hot spots in this area here. But the cause is quite confusing because, like what Lina said, what Lala said, not many people have activities here, but then the fires are caused by human activities. So how come, you know? What kinds of activities are here when not many people say that they are doing any activities? Now, from people's perspective, the stars represent settlements. And so the settlements follow the river on the west side, which is the Kapuas River. On the east side, there's only, this is a minor settlement. It's actually a orangutan release station in this area. So this left side is Kapuas River. It goes up, further up, with two tributaries, Mangkutup River and the Muroy River. And here there's 14 settlements from the southern to the northern tip of the KFCP boundary. And people living there have activities on both sides of the riverbank. Some settlements are located on the left side, some are on the right side, but when they do their activities, they do on both sides. And so activities can sort of be distinguished according to proximity from the river. So on the river itself, you have a lot of fishing, you have gold mining, especially in the northern part. And then after that, you go further, you go on the banks, and you have strips of mineral soils, which is good for rubber, rattan, some rice cultivation on the thin peat, and some fishing. And then further, you go to the thicker peat, and you start seeing more logging, more hunting, and still a little bit of fishing. And this route, this Kapuas River route, is a very active commercial route. So there's a lot of, what do you call it? People selling things up and down the river. There's a lot of, people going up and down. Because there's limited road access. Road access for cars, at least, goes up to here, and then starts up there. So there's a big chunk where you cannot access it unless you go by water. So the canals and the rivers, those are the main access routes. And you can imagine before PLG, before the Ex-Mega Rice project, this area did not have canals and was inaccessible. But now afterwards, people have a lot more access to it because of these canals. On the eastern side, the border, the eastern border of the KFCP boundary is the Mentangay River. And so the settlements here are temporary, seasonal, and a lot of activities are towards this side of the river. So it's mostly inside the KFCP activity, the KFCP area. And from downstream to upstream, you have different types of activities. Upstream ones, you can still have logging because the forests are still good. But then when you go down, you start seeing a lot more fishing, and then there's some charcoal and fishing and rubber on the southern part. So we collected a lot of information and from many different sources. The main one being dialogues with many informants, mostly across 4 fire-prone villages. And this was conducted more intensively within a year, from October 2010 until October 2011, where Lina, Lala, and Yayan took part in the last leg of that. And then we also had expert dialogue, so we talked to a lot of people as the need arises. So it turns out I needed to know a lot more than what can be gained from the field. So I had to talk with peatland specialists, I had to talk with ecologists, many dialogues with experts. And also field observation, going to the places where these activities are conducted or where the environments are similar to the activities where the activities are conducted. And this helped us understand the interview data and seeing the environment and then matching them to seeing like, oh yeah, I can understand that, or wait a minute, that doesn't make any sense. When I go to the field, the environment looks like this, how can they do that? So these questions started popping up only after going to the field. And also participatory observations. trying to do the activity as it's done by local people. However, this was very challenging because when we come, it's usually a few weeks to a few months, but then it's spread across villages. And so for one village, we could only stay at most 2 weeks, maybe 2.5. And that was not enough time first to catch the activities in action, because sometimes the timing is just mysterious to us. Another thing is some activities you have to build some trust first, so they have to see you quite a lot back and forth before they can start showing you what the activities are. And partly because some of them are illegal or hidden or just not something they would try to reveal the first time they know you. And also physical access, because the fires are happening in the dry season when access is very difficult. The water levels are low, and then the main transport is by water, so when there's low water level, it's hard to get anywhere. But by doing this, it can reveal the role of fires in these activities. And also, to complement that, I did, with some help from Wim and from Arif, I did some spatial analysis of burn scars and hot spots. Although sometimes I find that the burn scars, some burn areas are not categorized as burn scars according to the burn scar maps. So this one is a 2009 burn scar, and on the field we found burns very, very clearly, but the only burn scar that was registered was that one. But in general, it was a pretty good guide to understanding where the burns are located. Also understanding, using MODIS hotspot data to understand how fires spread. So here is my attempt, and this is of course preliminary, so this is trial and error, using a technique that was developed by Stines and Fogarty before for the entire East Kalimantan, which is a big area. I tried to use it in KFCP, but it's very time consuming. There's like thousands of hotspots, and you have to go through one by one, trying to figure out if these are ignition points or are these spreading from somewhere else. So, but they could be very helpful. So for example, I could use them to detect spread patterns. Like there's one fire that started on 20 September, and then that was followed by subsequent fires nearby and subsequent satellite passes. And it looks like they start here and then they go up. So for instance, things like that.
What are the different colors?
The different colors, the red one is where they ignite, and then subsequent smaller circles indicate that was the first day after or the second day after, something like that. And also some interview-based maps. So this is quite imprecise, but at least we could kind of overlay it with a map, because it was based, we used a base map. Oh, I'm sorry. We used a base map that was already spatially correct. I mean, and so we just draw on it. So first is to determine what is possible and what is more likely to be the cause. So I didn't know what people do, what people did, and so first it was creating this list of what people do in the various seasons, sometimes just to make sure when they're done. And turns out there's a lot of dry season activities, wet season, and interseasonal activities. And then focused on, and eliminated things from there. So if it's not in the dry season, then there's very little chance that undertaking it would cause fire, because when it's in the wet season or interseasonal time periods, everything is very wet and it's difficult to start fires, or even if you can start it, it won't spread. So we're left with a list of dry season activities, and then try to find where things are done that's not on peat, so we can kind of remove those too. So we have now a shorter list, and then we really scrutinize what is left. So the next thing is, on the top of the list is what needs fire for that activity to happen. And so from this longer list, and we determine a shorter one that seems to require seems to have more need for fire than other activities that are done. So sometimes there's new possible causes because when we conduct interviews, we hear new things. So for instance, there's this idea of arson that keeps popping up, and then idea of snares, which is a type of hunting technique that may benefit a lot from fires because of preferences of animals to areas that have been burnt recently. So I'll just go through the likely causes because of our time limit. So Lala before talked about nguruhi. This is a traditional fishing activity done by searching for fish trapped in receding ponds. So it has to be done in the dry season because the ponds have to be receding to a point where it's dry enough that it just traps fish inside. And it has to be small enough so that it's easy for one to just catch it with with your bare hands, basically, like this guy is doing. And nguruhi is from Indonesian keruh, means to make muddy. So either they're talking about yourself making yourself muddy because the whole thing is like a mud pond, but also because the activity causes what was undisturbed small ponds that had a layer of clear water to become muddy because of the action of agitating the water to find the fish. And so here is a picture of people trying to. This is depicting what could happen if there was no fire, which is a very hard process of lifting up a huge mat of roots of sedges to find the ponds that are underneath. So actually the vegetation can overgrow these small ponds. And imagine if you don't use fire, this will not allow people to do the activity. I mean, if there's no fire. So by seeing the counterfactual of how hard it was not to use it, it makes really a lot of sense to see that, oh, okay, yeah. If you burn, it clears the vegetation, makes it easier to find these ponds. It makes it easier to move around because one pond is not enough. Sometimes there's nothing in it and you have to jump from one pond to another, like a bee jumps from one flower to another. But from one pond to another, if you can't find it, if you can't travel from one place to another, it makes it very difficult, and it makes it very obvious that yes, of course, you need to burn. The season is very mysterious, ephemeral, because it's determined by the water level. So they say it starts about 1 month after the start of the dry season when the waters start to recede. But then again, it's uncertain sometimes when the dry season occurs. And from one place to another, the movement of water is a little different. So it's difficult to know, oh, okay, so this time I have to go there because that's where this activity is occurring. So that's what I mean by the problem of timing. And it lasts about 1 or 2 months. It lasts longer. It lasts longer if water recedes slowly, and shorter if it recedes faster. And so it depends on the topography and also the hydrology of a local place, that determines the speed at which the season starts and ends. So fish is normally eaten, it's not sold. This is more of a subsistence kind of activity. It's more of a social kind of activity. Women, men, children come there, and then sometimes they go from a small group of 3 to large groups of 40 because they congregate at the same place. And sometimes there's one village meeting another village accidentally in the same place, so it becomes quite a big group. And so looking at some rough sketches of where the activities are located, it looks like it can be done in all types of soil. So it's not only on peat soils, but it extends, it can be done in thin peat. It can be done on thick peat as well. And some villages have locations that are on both sides of the river. And it makes it easier for them, let's say, to say, okay, if this one's not allowed or this is not productive, then we move to the other one. And just based on some preliminary talking to some people, they say it's quite possible that if we are not allowed to do this in the KFCP site, then maybe we can move out. But there's also some saying that it's not that important. I can stop if it comes to that.
Yeah. What are the blue lines?
The blue lines are where the nguruhi is conducted. But these are just sketches, so it corresponds to, for instance, this one is a small river coming in. This one here is the end of a canal, and then, yeah. And so looking at hotspot data, it looks like sometimes it coincides with ignition points, which are also located near the access areas of the access points of these nguruhi areas. So for instance, when we came here, we had to stop in this location, and then after that walk to do this activity. And then when I looked at the 2009 hotspot data, there was an ignition point there. And there's also the same, sort of the same evidence, but this is something that I would need input on because it's sort of a bit difficult to conduct this kind of analysis. And at least for these cases that I found, for instance, this one, the fire spread for about 7 days, but this really depends on the parameters that I use for the analysis. So if you want to talk about it later, then we can. And another one is electrofishing with batteries. This is illegal, so I blacked out the guy, but this is how the contraption looks like. There's an electric prod there, a battery that looks like this big, and it's inside a basket, a fish basket, where the fish are just put in. And this whole thing is about 7 kilograms or 10 kilograms, empty. So it's quite a difficult thing to do, especially if the terrain is sort of wettish bogs and everything crumbling down when you step on it, kind of situation. But they're more flexible than nguruhi because they can work in areas that people who do nguruhi work, and they can also work in areas that are not suitable, which are, for instance, like these larger ponds, where you can imagine if you try to catch fish here and the fish just runs away. And again, burning provides access for people who engage in these activities. Sorry. Huh?
The idea to try to touch the fish with the prod, or just
No,
put
no,
the
no.
prod in the water?
Put the prod in the water, click the switch, which is just a nail touching another nail, and then bzz, kind of thing. So yeah, it's quite dangerous because this guy is actually prodding in the water he's in. So it's high risk and also high investment. I'll talk about that a bit later. So this one can be done in all soil types by looking at the map. And there's locations on both banks, so there's a similar concern of displacement later. There's high risk, as I mentioned before, it's quite dangerous. Also illegal and frowned upon by neighbors. And there's quite a high investment for buying this whole contraption, the whole, tool. And so this is something of an economic activity rather than a subsistence for fun, social kind of thing. It's completely not social. You can go with yourself or one person, but that's about it. And you need high returns for it. And so therefore, it seems to me there's a lot of more motivation to make this activity easier, thereby gaining more returns for the same amount of labor you put into it, compared to nguruhi activity, for instance. So there are some cases where the place where you do nguruhi coincides with the places where there's an ignition point. For instance, this case, in 2010 during the wet season, we went in here and then had to turn back because the boat couldn't pass. But in the dry season, you would expect that the boat would have to stop much earlier than that. And this area is where we found an ignition point based on hotspots. So this particular case spread all the way here. So I don't know, it's about 20 kilometers, 10 kilometers, something like that. And it took about 13 days from this point to that point. And by then, it's meeting another fire that comes from this side. So, oh, sorry. And, oh yeah, it's illegal and it's not welcome by other fishermen because usually the people who do electrofishing come there first and leaving nothing for the other fishermen like the Nguruhi people. The next one is beje. These are artificial ponds to entice and to trap migrating fish. Migrating in the sense that they laterally migrate when the Kapuas River goes up. They flow out to the floodplains and then they settle there, they breed, they feed, they, you know. And then when the water recedes, this pond is made such that it makes the fish feel more comfortable being there instead of going back to the Kapuas River. And these are located usually in burnt, thin peat, and on mineral soils. So this is our observation not in Kapuas, but in Barito River. This is the next river to the east. And usually they're located on open areas. And there's a forest edge, something like that, but usually open areas. And that's an example of one pond. It's very long. And the fires are used to maintain the depth of these ponds. Because if you can imagine, these vegetation can just overgrow the canals and make it, in time, if you just neglect it, it will just fill up again with vegetation, and therefore there's no difference in depth between the bottom of the pond and the rest of the landscape. And they do lots of things to make fish feel welcome there and therefore trap themselves in the dry season. So they install branches and then they sometimes, you know, I'm not really sure how, but they encourage water plants to settle in the ponds, on top of the ponds, because they think that the fish like it better like that. And then harvesting is done in the dry season because then the fish are trapped. There's less water you have to deal with, and you can just, you know, scoop it much easier that way. And so these are expensive, even more expensive, because there's a lot of labor costs. You cannot make it yourself. And so therefore you really need some financial capital to do this. The rich people can do this. But then once you put this on, there's low input. Maybe you need to guard it once in a while when the harvesting season comes to avoid poaching. Usually people with electrofishing tools come in and then zap zap, or they come in and then put poison and then the next day all your fish are gone. But then we have limited field observations in Kapuas River itself. Our observations are from other river basins. But then there are interview data that suggest that some fire incidents are related to the act of maintaining these beje activities, these beje ponds. But you know, spatial data and things like that, we're still lacking. Another thing is floodplain fishing management. There's a system, there's a term for it called seha, and this is what Lala was talking about before. It's when you have peatlands or thin peatlands that are burnt, and then it's maintained to be a clear area like this so that it can be used either for locating bejes or for conducting other wet season activities. And so the maintenance is done in the dry season. but then the actual fishing activity is in the wet season. So there's this interplay. So for instance, this one is taken from Suruyan, is it? Oh, sorry, from Katingan, where they conduct, they have similar systems, and here they burn expressly to maintain this particular seha.
How often does that happen?
I think they follow the biomass condition, and so if it's still a little bit, then they don't burn. But it also then links quite well with the El Nino, the dry season ups and downs. So maybe about every 2 to 4 years, depending on when the dry season comes. And then another one is rubber planting, but on peatlands. So there's two types. One is a traditional rubber planting that's done in mineral soils like this. And a lot of them are associated with Sweden rice cultivation. So after a few cycles of rice, then the rice garden, the Sweden rice activity is moved somewhere else, but then rubber is planted in the same area. But then there's another type, which is separately planting the rubber on peat soils, deep peat, thin peat, next to canals. So it's not really technically peat soils, but for instance, these canals here, when they were dredged, the underlying mineral soils are dredged up, and then they were sort of dumped on the banks, and therefore the banks have a mix of peat and mineral soils. And that thin strip along the canals are used to plant rubber. And this is done because there's a lot of land scarcity. Even though people always think there's a lot of land, like what Lala was saying, but really the areas next to the Kapuas River with all the good soils for rubber is taken, either inherited away or sold or whatever. But they're just taken, and most new households that want to acquire rubber have a hard time. And also, in about 2005, people stopped logging because there was the logging ban that was done by the government was felt very hard on the local people. And so that was basically the end. Before, logging was one of the main economic income sources, but that died. And so now people are struggling to find a replacement for logging, and they're trying to catch up by planting rubber. So the problem is that you have to burn to clear the land. And then even though you're targeting the small strip, sometimes it goes outside the small strip. And it seems to me that there's limited experiences in this peatland cultivation, because before, traditionally, there's a long history of rubber cultivation, but on mineral soils, not on degraded peatlands. And so this is sort of a new adaptation or a new way to adjust to a change in both economic circumstances of losing logging and also the environment that they're left with. And so now there's still a strong belief rubber will grow on these peatlands, but then sometimes in some villages who have tried and repeatedly fail, they've started to see that, okay, there's something wrong here. They're not behaving the way that they should, because every time they plant, it gets burnt, or their growth rate is so slow that they're overtaken by other plants. And they're usually not intensively managed. And so the weed accumulation, because it's not managed, would lead to a lot of fuel for fire. And then there's some potentially likely causes that's difficult to ascertain whether they're true or not, but it keeps popping up either through spatial analysis or through our interviews that it's hard to avoid. One is arson. There's a few types, social jealousy, which is a bit difficult to explain, but it's like, if my rubber garden gets burnt and yours isn't, I feel bad, and I think you should feel my feeling, and so I burn your rubber garden. When I first encountered it, it was like, what? I'm sure you have a problem like outside of this. Maybe you have some conflict somewhere else. But they're like, no, that's basically it. pyromania and some land acquisition or land speculation kind of motivations. And also snaring. It seems like when there's areas for snaring, there's a burn scar. So, but I feel maybe there's a spurious co-location because people who set snares need to locate it near where there's water during the dry season, and the water is usually next to canals. But then these canals are usually where the fires happen. So we can't really deduce if the cause of the fire is the snare activity, or is it because they're just always located where the fires are. And there's a belief that deer like the ash, eat the ash for its salt, or maybe eat the small vegetation that grow afterwards. So there is some basis for thinking that the hunters would start the fire. So in conclusion, understanding the causes of emissions can be challenging because there's some social sensitivities, there's some illegal activities, and rapport is really important. And spatial analysis is not really enough to understand the displacement because you have to know who is emitting, why are they doing it, and what kind of interventions can cause these kinds of displacement. And this cannot be done with a survey. Again, because it's sensitive, but also complex. There's a lot of environmental, social, and spatial stuff that you need to understand. So in conclusion, minor activities can cause major emissions. Even things that are done by a few number of people can cause a lot of fire, a lot of emissions. Secondary things, secondary income things, social activities that are done for fun, or done by a small number of people, or by everyone, but for a small time, like Nguruhi, for example. Rubber planting on peatland is sort of an adjustment to this new economic and environmental condition. And so sometimes I feel like if they knew that this is not working, or if they knew there's a better way, maybe they would choose that better way, but there's no information coming in.